What is second law of Newton now? Newton's second law of motion says that the rate of change of linear momentum of a body with time is directly proportional to the net external force applied on it, and this change takes place in the same direction of the applied force. Observe once again, the rate of change of linear momentum of a body with time is directly proportional to the net external force applied on it, and this change takes place in the direction of applied force. Fine. First and foremost, what do you mean by linear momentum? That is the first point one should understand here. Linear momentum, we represent that one by the letter P. That is nothing other than mass of the body into its velocity. I just repeat, linear momentum is nothing other than the product of mass of a body and its velocity. We generally write this one as m into v. M stands for mass and v stands for velocity. What exactly this second law of Newton says now? Rate of change of linear momentum. What do you mean by that? Simply speaking, change in linear momentum. Change in linear momentum divided by time. This is what we call it as rate of change of linear momentum of a body. This change in linear momentum of the body with respect to time, according to this second law, is directly proportional to the force that is applied on the body. I repeat once again, the rate of change of linear momentum of a body with time is directly proportional to the net external force applied on it, and this change takes place in the direction of the applied force. So you have learnt about what is linear momentum first. What is linear momentum now? It is the product of mass of the body and its velocity. We generally write that formula as m into v. Now what do you mean by rate of change of linear momentum? It is nothing other than change in linear momentum of the body divided by time. That is what we call it as rate of change of linear momentum. This particular law gives us the measurement of force. This gives us the measurement of force. That means how much force that is needed for a body to move. How much force that is needed for a body to stop. That measurement is going to be given by this second law of motion given by Newton. Now look at carefully. If P is the linear momentum of a body, then differentiating P with respect to time, that of course we write it like this, dP bar by dt, that now is proportional to the force that is applied. So how do we write this equation now? Check it. F bar is directly proportional to dP bar by dt. Why we people are using this bar here? In fact, we know F bar represents that F is a vector quantity. What is a vector quantity again? The quantity which will have both magnitude, right, and direction. There are two different parameters we people have to consider. If a particle having some force on it, or a body is acted upon by some force, that force, whatever we are discussing here, will have magnitude as well as direction. Those quantities in physics which will have both magnitude and direction, we just call them as vectors. Here, force is a vector quantity. That is why we are using this one as F bar. Similarly, if you consider linear momentum, that also we used to represent it by P bar. Even linear momentum also is a vector quantity here. So, according to second law of Newton, F is directly proportional to dP bar by dt. That otherwise we can rewrite it like this. F bar is equal to d by dt of mv. Observe this equation carefully. M into v bar, that is what we call it as linear momentum of the body. Therefore, F bar is equal to d by dt of mv can again be rewritten this way. That implies m into dv bar by dt. That of course we can write it like this as ma. That is mass into acceleration. Observe this wording carefully please. Mass into acceleration. What is this one equals to? According to second law of Newton, force can be written as mass into acceleration. So, this measurement of force can be given by second law of Newton. So, F is equal to ma. Now, the question is, what do you mean by force? Force is nothing other than that external agency which either changes or tries to change the inertia of a body. I repeat, force is that external agency which either changes or tries to change the inertia of a body. For example, imagine there is a huge wall like this. Let us take this one as a wall. You just want to make this wall move towards my left. Imagine you are applying a force with your hands. Will it be possible for you to move this wall towards left, please? Will that force be enough for this wall to move towards left? No chance. Means what? In this example, that force is trying to change the inertia of the body, but that force is not sufficient and enough for that wall to move towards left. It's not enough for us. Therefore, you can say this force is simply trying its best to change the inertia of the body. Suppose if you take another case, like there is a ball like this. Observe carefully. That ball is to be kicked towards my right. Come on, you apply some force by kicking it, automatically ball used to come into motion. That means if you just compare these two examples, here wall is unable to move by the applied force, whereas here ball is just running with the force what has been applied. So, what you can understand in both the cases? In the first case, wall is not going to get the same force what is required for it to move. The force what we are applying on the wall to make it move is not enough for it to come into motion. That is why the force that is applied is simply trying its best to change the inertia of the wall. That is, it is already at rest. It will be at rest only when the force is not sufficient for it to move. Whereas in the second case, the force whatever you are applying is just sufficient for the ball to move. Therefore, the ball comes into motion. That means it is now changing the inertia of the body. So, what we should understand about force, please? It is that external agency which either changes or tries to change the inertia of a body. And what are the different forces we people are finding in nature? In fact, several types of forces we have, but mainly 4 basic forces we people used to deal with. Why we people are calling them as basic forces? They are the forces which in fact in the nature we people are observing. They are the fundamental most values of forces. That is the reason why we people are calling them as basic forces. What are these 4 forces? Just look at the first one, gravitational force. What is this gravitational force? For example, when 2 bodies having masses m1 and m2, when they are separated by a distance r, then a force of attraction that is going to exist in between the bodies. That force, due to their masses whatever we people are observing, that is called gravitational force. In fact, just because of gravitational force only, all the planets are in a position to move around the sun. If suppose gravitational force of sun is absent, then no planet will be bound to the sun. Underline that concept carefully, right? Therefore, gravitational force is one of the basic forces what we find in the nature. And come to the second one, electromagnetic force. What is this electromagnetic force? The force what we observe between 2 charged particles. For example, there is a positive q charge which is separated by a distance r from another charge that is minus q. I am repeating, a positive q charge is separated from another charge negative q at a distance r. If this is the case, every one of us we know there used to be Coulombian attraction between these 2 charges. That force, which of course is one of the basic most forces by means of which either 2 charges are attracted by one another or repelled by one another. When do you find repulsion? If both the charges are like charges, like plus q or minus q, you find there will be repulsion between them. Whereas one positive charge and one more negative charge, when they are separated by certain distance r, automatically we find attraction between them. That is what we call it as electromagnetic force. This in fact is called Coulombian force. Now come to the next one. Third kind of forces are strong nuclear forces. The nucleus is going to have some amount of force to apply on the nucleons together to keep them in its core. If I consider this one the nucleus, inside the nucleus protons will be there and neutrons will be there. We call both of them as nucleons. We all know all these protons and neutrons are put together inside the core of the nucleus by applying some force by the nucleus itself. What is that force to be called? That's called strong nuclear force. Likewise, in few cases, weak nuclear forces are also going to be observed. The point is, nuclear forces are common, whether their strength is more or less. According to that, we used to specify few forces as strong nuclear forces and few forces as weak nuclear forces. So these are basically four major kinds of forces what we observe in our daily life.